I upgraded the motor in my turbo blower and the results are astonishing. The first versions worked well, but were severely underpowered. After using them for about a week, I realized I was well overdue for an upgrade. The motor I chose for the first one is pretty much the weakest and most basic motor you can buy. This new motor is about as powerful as a brush motor can be, while still using a single 18650 cell. Same housing, different motor, completely different results. The purpose of this build is two-part. One, I need something that has a more mellow pressure than my leaf blower or my air compressor to clear dust off my work surfaces. That way I'm not flinging stuff about. And two, I need a venting system for solder fumes. This will serve as my fan for that setup, I just need to dial it in first. The setup for these handheld devices is simple. It's a single 18650 cell, a TPU 1S BMS board, switch, and a potentiometer motor driver. And of course our motor, which we can switch out easily by using different backplates. In my first video, I showed the two designs I came up with and tested them using the distance they could push sawdust. After reviewing that footage, I knew I could do better. I went back and tweaked my second design to include a ball bearing to center the shaft and use the same type of impeller I used for the first. I have retested those smaller motors in these shells alongside these new motors to get an apples to apples comparison. This leads me into our first test. Since one of the main applications is to clear dust, we're going back to the sawdust test. This time I'm using a more visual measuring stick, keeping my starting distance more consistent, using the smaller 130 motors first. The V1 shell gets a clear push distance of 12.5 inches. Pretty impressive for such a small motor. The V2 shell gets a clear push distance of 9.5 inches. Not as good, but still doing something. Switching over to the stronger motors, we get a much better result. The V1 shell gets a clear push distance of about 15.5 inches, which is a decent increase in push distance. The V2 shell gets a clear push distance of 16.5 inches, an insane jump from the smaller motor, showing that this design does have improvements from the first, it just needs the higher RPM to utilize them. Now on to the smoke test. Here I set up a 0 point with a stick of incense to show the distance that these can pull smoke. This is the most useful test to see the fluid motion these cause in the air. Using the smaller motors first again, the V1 shell is able to pull a stable stream of smoke consistently at about 11 inches. Past that, our stream gets a little wild. The V2 shell has a better suction distance even with the smaller motor, maxing out at about 15 inches for a stable stream of smoke. My theory here is that the intake with the 3 slots is creating a better vortex effect than our open impeller on the first design. That and the housing must be at play. Moving to the stronger motors once again, the difference is pretty decent. The V1 shell is able to pull a stable stream of smoke consistently at about 15 inches. The V2 shell again has a better suction distance out of the two, maxing out at about 20 inches for a stable stream of smoke. Surprising considering it feels so much weaker than the other. Now on to our new test. After watching a ton of HVAC videos and not wanting to spend the money on a professional manometer, I made this thing. What it does is it measures water column in inches, which should get us an idea of how much pressure these things are generating. I'll admit I'm still tweaking this, so it gives me the data that I'm looking for. If you know more than me about this, please do share your critique in the comments. I have 2 pipes here, one to measure static pressure, the force being extruded on the walls of the chamber, the other to measure dynamic pressure, the speed at which air is flowing. If I know the area of the vent, I should be able to calculate CFM based on the 3 measurements, dynamic pressure, static pressure, and area of the vent. But I don't think it's working correctly, so I'm not bothering with the math on this one, but check out the results. Keeping this first round quick, putting the weaker motors up against the intake makes the water wiggle a bit, but I can't see any measurable change, either with V1 or with V2. Switching to the more powerful motors, however, gives us a result. Here, the power dynamic is switched. V1 generates a huge spike, 2 to 3/16 of an inch, showing it's definitely got some good dynamic pressure right at the nozzle. V2 is weaker here, I think in part due to its larger exhaust port, showing only a small change of only 1/16 or less. So what's the takeaway? V1 is better with the weaker motor at moving dust and feels a lot stronger than V2 overall. However, its intake does not allow a good vortex to form, so even though it's pushing out air faster, it's not better at suction at distance because it can't create a steady vortex or stream. It's only better at close proximity dynamic pressure thanks to its tighter housing. That's shown with the water column test. V2, while it underperforms with the weaker motor at pushing dust and feels very weak, still manages to pull smoke at a better distance in both tests. I think this is due to its housing shape and the 3 slits allowing a better vortex to form. The real shocker here is that even though it's got lower dynamic pressure on the water column test, it still pushes dust further with the stronger motor. This is what leads me to believe its dynamic pressure would be greater than V1 if it had the same sized outlet. On the first video, I recommended V1 if you were making this yourself. I would now strongly recommend V2 with the upgraded motor plate. The performance difference is incredible. This thing, I feel, outperforms devices that you would buy off the shelf for $25–30 a pop and is only $10 to build. Super fun, super cool, and definitely taught me a lot about the difference in static and dynamic pressure. I'm probably going to be weaning away from this project now. I may post a video on my solder fume extractor once I build it. I still have a little bit of brainchilding to do there. And then eventually I need a dust collection for my shop that I hope to implement this in. I may round back to it with a brushless motor if the engagement is high enough on this video. The last one that I posted is sitting at about 200 views. Not super happy about that, and like 5 comments. I put a lot of work and energy into these videos. If you enjoy them, please do leave a like, comment, subscribe, and there will be affiliate links down below where you can order the parts that you need to build one of these yourself. I'll be posting a full tutorial at some point on the wiring, which is just real simple, 5 minutes long, and then the chassis for these are up on my printables. Other than that, if you're interested in engineering projects like this, please do leave a like, comment, subscribe, and let me know what you'd like to see next. As always, happy printing.
I'm just in a little restaurant, and I'm your melody. Think of what it is you want. You ain't never had a friend like me.